Section 6.3, Applications of Algebra. Whenever you see the word application, that's going to mean story problems are coming about. So first thing we're going to learn how to do is we're going to learn how to translate some expressions from English into math, and then we'll start solving the story problems after we have the translations complete. So first let's get familiar with some phrases. 6 more than a number. So if you ever hear the more than phrase, that's going to be addition. But notice the order that it's written in. It is not 6 plus x. It is x plus 6. So more than and less than always go in the opposite order than you think they're going to. A number increased by 3. Notice increased by is also addition. 4 less than a number. Again, focus on the less than. Focus on the order that it's written in. It is not 4 minus x. It is written in the other order, x minus 4. I'm honing in on that because that's a very common mistake. People go in the wrong order on that phrase. A number decreased by 9. So decreased by is also an indicator of subtraction. Twice a number. So anytime they say twice, 3 times, 4 times, double, triple, any of those mean multiplication. 4 times a number, again, multiplication. 3 decreased by a number. So notice on the decreased by, you go in the exact order that it's listed. The difference between a number and 5. So remember, difference also means subtraction. 4 less than 3 times a number, so that'll look like 3x minus 4. 10 more than twice a number. Again, notice the order, 2x plus 10. The sum of 5 times a number and 3. So sum means addition. You've got 5 times a number, so that's your multiplication, and then you're adding it to the 3. 8 times a number decreased by 7. So that'll be your 8x minus 7. 6 more than a number is 10. Now that is important. Whenever you see the word is, they have turned you into an equation. So the word is will always be the location of your equal sign. 5 less than a number is 20. So that would look like x minus 5 equals 20. Twice a number, so 2 times x, decreased by 6 minus 6 is equal sign 12. All right, last one. A number decreased by 13, so that would be x minus 13, is equal sign 6 times the number, 6x. So we're going to use those translations in order to start solving word problems. So when you solve a word problem, there's a steps, procedure that you need to follow. First thing I want you to do is read the problem carefully. You'll probably need to read it more than once to make sure you're understanding exactly what they're asking of you. If you can, draw a picture, label the picture. It could be helpful later on. Once you have your picture drawn, decide what you're actually being asked to find. What are you solving for? When you figure that out, choose a letter to represent what you are solving for and write down what it means, because sometimes later on you could get confused if it's not written down. Once you have your variable identified, you're going to want to turn the word problem into an equation. That's typically the hardest part. Solve the equation for the quantity you're looking for. Make sure you have answered the question, because sometimes they ask more than one, and sometimes they ask it in a roundabout way, and then check the answer to make sure you are correct. So let's try a problem. Jana purchased a copier for $2,300 and a 1-year maintenance protection plan that cost 2 cents per copy made. If Jana spends a total of $2,626 in a year, which includes the cost of the copier and the copies made, determine the number of copies she made. Okay, so first thing we want to do is decide what we're solving for. In this problem, we're solving for the number of copies made. So I'm going to let that be represented by n. Now here's what we know. She had 2 items that she bought. She had to purchase the copier, plus she has to pay per copy, and then this will equal her total expenses at the end of the year. So is there anything we can fill in right off the bat that we know? Well, we know how much the copier was. That was $2,300. We also know how much her total expenses were at the end of the year, $2,626. We also know that it cost 2 cents per copy, but we don't know how many copies she made. So that's where your variable is going to come in. It is 2 cents per copy times the unknown number of copies. And then it's our job to solve for n. So the first thing we want to do is to subtract the 2,300 to the other side. So we'll have 0.02n equals 326. And then we want to isolate our variable. So we'll do that by dividing both sides by 0.02. And I would just let my calculator do that for you. And that'll tell you how many copies she made. It's going to be a big one. 16,300. And then you should properly label this. Copies. If you want to check your answer, simply put it back up here in the top equation. If you took 16,300, multiplied it by 2 cents a copy, added back the $2,300 that she paid for the machine, it should equal her total expenses for year 1. Let's try a different one. Mark IV Construction Company purchased 100 acres of land to be split into 3 parcels of land on which to build houses. One parcel of land will be 3 times as large as each of the other 2. How many acres of land will each parcel contain? Okay, so I think this is one of those problems where it's helpful to draw a picture. So let's draw our plot of land. We're going to break this into 3 segments. 2 of them are going to be the same size. 1 of them is going to be 3 times that amount. So there I have segment 1, segment 2, and segment 3. Now, I do not know how big any of the segments are, but I know if I take segment 1 plus segment 2 plus segment 3 and add it together, it should be the total amount of acres that I bought. If not, I'm wasting land or using someone else's land. So I know that all together there was 100 acres purchased. So when I add these 3 plots of land together, it's going to be 100. Now I have no idea how big the first plot of land is. So I'm going to call that X. So I know that the size of plot 1 is X acres big. Now I also know that the second one is the same size, so that one's also going to be X. And they told me that the largest was going to be 3 times the other ones, so that'll be 3X. Now I'm going to add my 3 variables together. 1X plus 1X plus 3X makes 5X. And then I can solve for X by dividing by 5. And I have that X is 20. Now you have to make sure you answer the question. The question was not what is X. The question was how large is each plot. So the first plot is 20 acres. The second plot is 20 acres. And the third plot is 60 acres. So make sure you answer the actual question. If you just said 20, you would have been marked wrong. Let's look at another one. Javier is building a rectangular sandbox for his children. He has 34 feet of wood to use for the perimeter of the sandbox. What should be the dimensions of the sandbox if he wants the length to be 3 feet greater than the width? Okay, so again, I like to draw pictures on these types of problems. So we know he's building a rectangular sandbox. We have no idea how big the length is or how big the width is. That's what we're solving for, length and width. What we do know is the perimeter. They said that the perimeter has to be 34 feet. Well, remember the way you find a perimeter of a box is you take 2 lengths and 2 widths added together, and that gives you the perimeter. Well, in this problem, they told us that the perimeter was 34. so I can replace the P with the 34. The problem is I still have too many letters in my equation, so I need some more information. Let's call the top of the box the length and the side of the box the width. Now if we go back to the description, notice it says the length is 3 feet greater than the width. So if I translated that, length is 3 feet greater than the width. So what I could do in my equation, instead of using L, I could use the width plus 3, and I would be able to solve for the width. Make sure that you distribute your 2 and that you combine your like terms. You're also going to want to isolate your W. Divide both sides by 4. And you know that the width of the sandbox is 7. Now that's great, but they asked for the dimensions. So remember that the length is the width plus 3. So the length of the sandbox is going to be 10 feet. 10 feet wide, long and 7 feet wide. Last example for today. Kim is selling her homemade jewelry at a craft show. Determine the cost of a necklace before tax if the total cost of the necklace, including an 8% sales tax, is to be $34.56. So in this situation, a picture is not going to really help, but what we do know is usually when you go to the store, you have to pay for the price of the item, plus you have to pay for the tax on the item, and that equals the total bill. Okay, well here's the thing. We don't know how much the price of the item was, so let's call that X. We don't know how much tax we paid, but we know we paid 8%. So whatever the item cost, we have to pay 8% of that to get our tax figure. So you'll have to take 0.08 times the price of the original item. If you added those together, that would be the total bill, which was $34.56. Now, where a lot of people go wrong is right here, is with combining like terms. Remember, even though there's not a coefficient in front of that X, there's always the number 1 there. So if you take the 1 plus the 0.08, you'll have 1.08x. And then you can solve for x by dividing each side by 1.08. And that will tell you how much the item cost. This item started off at $32. If for some reason they wanted to know how much the tax was, all you'd have to do is take the $34.56 and minus the $32, and you would have paid $2.56 in tax. Last but not least, occasionally you'll come across a story problem that can be solved in terms of a proportion. So let's look at an example. For the cost of water in the city of Bradenton, Florida, it is $2.14 per 1,000 gallons of water used. What is the water bill if 25,000 gallons of water are used? In these situations, you can often solve them by setting up a proportion, which is a ratio equal to a ratio. A ratio is just a fancy name for a fraction. So first, take the cost per 1,000 gallons. We know that it costs $2.14 for 1,000 gallons of water. The question is, how much would it cost for 25,000 gallons of water? The easiest way to solve these problems is with cross multiplication. So you'll take the 1,000 times x, and you'll take $2.14 times 25,000, and you'll solve for x by dividing each side by 1,000. And this will tell you how much 25,000 gallons of water costs, which is $53.50.